Alright, so now moving on from the current division rule and the voltage division rule, let's use this practice problem to apply these two rules to find these unknowns, which are I1, I2, and V3. So the two rules we would be using are CDR and VDR, even though this problem could be solved with a lot of other rules too. So now the one thing I know is the CDR is applied on parallel combinations and the VDR is applied on series combinations. So let's just start off from the left side. The first unknown is I1, and to find the current clearly, as you can see by visualization, I need a parallel combination here to apply CDR. But the problem is this entire area, this would this would need to be reduced into just one resistor here so I can find I1. So I'll just try to reduce all this. Let's just mark the nodes. The first node is here, the second node, the third node, and the fourth node. As you can see that this node makes clearly shows us that the 20 ohm resistor and the 40 ohm resistor, they are in series because these are the only two resistors connected to this node. So I can just combine them and write 60 ohms here. So this would make this 60 ohms, and this resistor would just go because I have already combined it. So now as I can clearly see that this 60 ohm resistor and this 240 ohm resistor, they are in parallel. So I can use this formula to just reduce them into one, and now the result would be 48 ohms. So now this entire area just goes away, and I have just one resistor here which is 48 ohms. And let me just redraw the circuit here to make things even more clear. So I have the new circuit like this. So the new circuit looks like this. I have combined these three resistors into just this one, which is 48 ohms. Now you can clearly see that these two are in series now because they are the only two resistors connected to this node. So I can just combine them and they would be 50 ohms. So sorry for the bad handwriting, 50 ohms. Now when I just combine them and write 50 ohms, I can clearly see that this resistor and this resistor, they are both in series. So I'll just combine them too. So now after combining all of the resistors into one, I get this 25 ohm value. And now if you still do not know how I got this value, you can see the previous videos in which I've discussed how you combine resistors in series and parallel. So now this looks like a perfect circuit to apply the CDR. So I'll just apply the CDR for I1. So the CDR states that I1, basically the current in the 25 ohm resistor, I will multiply the total current, which is 120 milliamps, multiplied by the other resistor in the parallel combination, which is 125, divided by the sum of both of these. So this will yield a value of 100 milliamps. The reason I keep the unit milliamps is because the unit of 120 was milliamps. So this is basically I1. So now let's find I2. So I'll just rub all of this. So now the next step is to find I2. Now I know basically the total current going into this parallel combination right here. So I'll now apply the CDR again, but I would need to combine all of this into one. So I'll just do the previous example, and I found the value to be 50 ohms. Now I can just give an overview about how I got this value. I combined these two, the 20 ohm resistor and the 40 ohm resistor, to be in series, and I just added them and I got 60 ohms. The new 60 ohms resistor was in parallel with the 240 ohms resistor, and I combined them and I got 48. This new 48 ohms resistor was in series with the 2 ohm resistor, so I just added them up and I got the answer of 50 ohms. So I'll just draw the new circuit again. So now this is a simplified circuit. I have I1, and which was 100 milliamps calculated in the previous step, and I need to find the value of I2. So I'll just apply the CDR. I can draw the zoomed in version, which is this, looks like this. 50 ohms, and this is the total current going into the parallel combination, which is 100 milliamps, and I need to find this current. So I just apply this CDR. I2 is equal to the total current multiplied by the other value in the parallel combination, which is the same in this case, 50, divided by the sum of the two resistors, and this yields I2 to be 50 milliamps. So now in the next step, I know that I have found I1, which is basically 100 milliamps. I have found I2, which is 50 milliamps, and now I need to find I3. So I'll just use the same concept. I would have to combine these two to form a parallel combination. So I know the total current entering the parallel combination, which is I2, and then I can use CDR. So combining these two would make, because they're in series, it would yield 60 ohm resistor, and I will just draw the zoomed in version. and this is the zoomed in version, and this is I2. One thing to keep in mind is that this resistor, it won't actually have an effect on our CDR formula, because the same current passes here, and this is I2 too, because there is no breakage between this. So I'll just use the current being put into the parallel combination for calculating I3. So I3 would be applying CDR I2 multiplied by the other resistance, which is 240, divided by the sum, which is 300. 240 plus 60. So the answer yields to be 40 milliamps. So this is I3. We're almost done. I have I3, and the last step is to calculate V3 with the positive terminal to be upside, and I can just apply Ohm's law now, because I3 is the current going into the 20 ohms resistor, and I can apply Ohm's law to find V3 to be I3 times 20, which is 40 divided by 1000, because it's milliamps, into 20, and the answer comes out to be 0.8 volts. So now we have found I1, we have found I2, we have found I3, and now we have found I3, V3 too. So the main thing to remember in a question like this, where you see a big circuit and you need to find everything, especially using CDR and VDR, current division rule and voltage division rule, is just start off from the first unknown from the left side and then move to the right side. And then the second thing to remember is that you need to assign the nodes, and then you need to combine resistors to bring the circuit into a shape on which you can apply your formula. The most important thing to remember is that the formulas of CDR and VDR are only applicable on these kind of configurations. So you have to bring the circuit into this kind of configuration by using series and parallel configuration formulas to find equivalent resistances and equivalent currents. So this is how you basically approach a problem with CDR and VDR. I hope this has made things more clear now.